Make sure your expected values still are the same 80 flies rearranged. Okay, let's move on to 11.2, which lucky for us has very little computation and we all have the calculator function. Life will be easier at 11.2, but we get to learn something new with our calculator that we haven't seen yet.
Matrix.
A matrix, yes. You reading ahead?
Yeah. I kind of like woke up and I was like, oh no.
Where are we? Oops, I'm going to
Yeah.
now. 154, section 11.2. It's all about what's called contingency tables, which I like to call two-way tables. Both are listed here. This is for when you have two categorical variables and you're looking for a relationship. Maybe you're looking to see if there's a relationship between people who are in high school, junior high, or college, and whether or not, I don't know, they go to the movies once a month. And so either they do or they don't kind of thing. So those are yes or no questions about the movies, and then categories as well for what kind of school you go to. So you would make what's called a two-way table with categories going across, categories going down, and then we'll talk about the questions that go with it. So before I go and fill you in on the details, I just want to look at the example for the table they gave us, a little explanation of what's there. They were studying people that had what's called amalgam restorations. They're talking about fixing people's teeth. And so when you fix people's teeth, in example 4, you can either use amalgam or composite. So some dentists or whoever is trying to decide if one of them is better or worse for people. Are there more, adverse reactions for one versus the other? Are they equally, the same kind of percentages in terms of who has issues and who doesn't? So they have this table here where they took a bunch of people. Some had the amalgam restoration, some had composite. And then they counted in those two groups how many had adverse health conditions. I'm going to use my paraphrasing here. And how many were okay. That's not the word you have there, but if you don't have adverse reactions, you were okay. So they just counted. They said, okay, there were 135 people who had this kind of restoration, who had some kind of adverse health reaction. And there were 132 of them who had that kind of restoration that were okay. So we saw these tables before, like back when we did probability, just how many were in each kind of group. 145 had this type of restoration and had some kind of adverse health conditions, and 122 had that type and were okay. Now look at what the claim is, and then we'll go back up above. It says test for independence between the type of restoration and the presence of health conditions. What that means is, does one affect the other? If I said, hey, Mr. Dentist, how likely am I to have some adverse health condition? If he says, well, that depends. It depends on if you use amalgam or composite. If the answer depends on what type of restoration, then those would not be independent things. But if it doesn't matter if they're independent, either type is not going to give me a higher or lower chance of having some kind of health condition. It'd be like if you said, hey, how likely am I going to get a raise? And I said, well, that depends on how often you've been late to work. So being late to work and getting a raise are not independent of each other. Where I wouldn't say, well, that depends on your favorite color. Your favorite color shouldn't affect whether or not you get a raise. So independent and dependent is there some relationship between the variables or not? Those are always the claims in this whole section. Are they independent or are they dependent? So now let's look up above where it tells you that. So we're doing what's called a test of independence. The HO will always be that the row and column variables are independent. And the H1 will be that they're dependent. Every time. So in this case, what is this variable measuring? What are we finding here in words? What do these represent? What are these?
Proportion.
Well, those are the
Categories.
proportions. But what are the categories of what? Are they favorite colors or favorite movies?
Material?
Material or type of restoration they called it. They're categorical always, but in this case it's the type of restoration. Type of restoration. And what are these measuring? Health conditions, whether or not you have adverse health conditions. Type of restoration and maybe chances of adverse conditions, health conditions. Are, I would maybe instead of chances I'll put presence, are independent. I'm gonna change one word here. Presence. I like that better, sounds better. Presence. So let me underline a couple of things. First off, your H0 always has the independent in it. Always. And then you're just describing this variable and that variable. So the one variable is the type of restoration, the other one is the presence of adverse health conditions, and we just say they're independent. And then guess what H1 is? That they're dependent. If you write it out once, I will not make you write it out the second time. As long as I know what they are. You need to describe the two variables. So either they're independent or they are dependent. Always going to be your two claims. From there, our calculator is going to do the rest of it. It's actually going to do a chi-squared test, but we need to enter our data into what's called a matrix. Let me turn the lights off and show you how to do this. Since we haven't seen this before, some of you are reading the directions on your notes and working ahead, which is great. Some of us need to see it. So the directions for this are the last piece of writing at the 2/3 of the way down the page, right underneath the HO and the H1. It says enter it into a matrix. I'll wait for this to get a little bit brighter. It's getting there. Can you guys see that? Getting there? So the matrix is kind of hidden. See down here where it says matrix in blue? Some of you have yellow on your calculator above the x to the -1 thing.
Yeah.
So to get that, because it's in blue or yellow and it's above this button, you have to hit the second button and then this one to get that. And it should look like this. Do we get to here? So that's the first thing, second x1. Then we need to choose edit. We need to create a matrix. So I'm going to move over to edit. And then there's all these names of these matrices. That's plural for matrix. So I'm just going to edit the first one. Some of you might have numbers here because somebody else already used your calculator and put some things in there. It's okay, we're just going to change them if you do have numbers. So I'm going to use matrix A, and I want to edit it, so I'm going to hit enter.
Is it clear to get all that out of there? Or?
No, just hit enter on matrix A. It'll change when we get in there.
Oh, okay.
Now you should be something like this. Mine says 1 by 1. Somebody else might have a 2 by 4.
Right.
So what size matrix do we have to fit our data here? How many rows and how many
2 by
columns?
2.
2 by 2. Important, it's always rows by columns. You could have a 2 by 3, which is different than a 3 by 2. Rows and then columns. Rows by columns. So I'm going to type over those numbers and change it to rows and columns. 2 by 2. Columns are, these are rows. These are rows, right? And these are columns. So 2 by 2. Oops. 2 by 2. So once I change it to 2 and 2, did you guys get yours changed?
Yeah.
You now should have a matrix here where you have 4 little numbers that you can type in. So I'm just going to type in my exact numbers that I have here. 135, And then, I can't see from here, 145, 132, and 122. So I've created the matrix in the calculator that matches my two-way table. Good there? Okay, so that's the first part of the directions we're telling you to do. Enter it in there. Now we want to do a chi-squared test. I think we have to get out of here first. I don't think so. So it's in matrix A. I'm going to hit stat and go over the tests like we've done before 100 times now or more. Probably more than that. And we're going down to just what's called the chi-squared test. Plain old chi-squared test. Waiting for my calculator to get there. It's on the way. There it is. Chi-squared test. You finding that?
Yeah.
We hit enter. It just wants to know, where did you put your observed values? Well, we just typed ours in matrix A. So we're going to leave it as A. If you had, for some reason, typed it into matrix C, you'd change that to matrix C. Well, ours is A. So we're going to leave that there. It's going to create the expected values and put them in B. You don't need to worry about this at all. The calculator is going to create the expected values for us. You can go look at them later if you want, but we don't need those. I don't care what color the draw's in. I'm just going to come down here to calculate and hit enter. There's my test statistic and my p-value. Did you get the same thing as I did?
Yeah.
Thumbs up. So for this particular problem, we wrote our claims. Step 2 is to get the test statistic, which is 0.70 or 751 if I round to 3 decimal places. Step 3 is to get the p-value or the critical value, but guess which one's easy in this case? P-value, we all have it in front of us. 0.386.
Bigger than alpha, so.
Which is bigger than alpha.
Failed to reject.
So we failed to reject H0. Did I write down alpha? I didn't. What was alpha?
0.05.
Thank you. So we failed to reject H0. I'm about to write my conclusion here in a minute. Questions about the calculator? The hardest part is knowing how to get in and find the matrix to edit it. Let's talk about where it is on here. The light cloud bars here. Where is it on your packet? I didn't hear you said. It says contingency tables on the lower left here on page 3. It talks about a test for independence. It has a nice formula. It still has the chi-squareds and the O's and the E's, but we're not going to do these by hand at all. If you go all the way down to the bottom, it tells you to do the chi-squared test that we just did, and it even tells you how to find the matrix. Yes?
In the test, are you gonna have a table set up, or you just got numbers randomly in the?
Most of the time I think they're in a table form. Sometimes,
set up.
just like with probabilities, sometimes they're not. But most of the time I think they would be. Are we okay where it is on there? And so we only have one last step to do, and we probably won't get to our last problem, but what's my last step? Write the conclusion. This is probably the easiest section for conclusions, where your conclusion is either the data shows that the variables are independent, or the data shows that they're dependent. So we're not going to talk about rejecting the claim that they're independent or supporting. We're just going to say the data shows that independence or dependent.
Yeah.
So because we failed to reject H0, it shows that they're independent because we did not reject this guy. Oops, yeah, that's H0. We didn't reject him, so therefore the data is showing that those variables are independent. Data shows that type of restoration is independent of adverse health reactions. go to my dentist and say, hey, which type should I have? Which one's gonna make me have a bigger chance of having some issues? People say, it doesn't matter, they're independent. One doesn't affect the other. So we didn't do the last example. I just wanna look at it real quick before you go. I lost my thing. There it is. What's the only thing that's gonna be different with this example 5 on the last page? The size of the matrix. What's the size of the matrix on this last one? 2 by 4. Right, it has 2 rows and 4 columns. Other than that, it's exactly the same. We're good? Have a fabulous Thanksgiving.
You too.
I will. I'll see you all on Monday. Ready for our very last section, and then get ready for the test.